we're going to be talking about the properties of matter. Now, there are two main types of properties, physical and chemical. But first of all, what exactly are properties? Properties are characteristics of a material that indicate what the material is. So basically, think about this picture of an engagement ring and wedding ring. You know, you can find these at like a Walmart or a Target for $10, right? So how do you know if it's real gold and real diamonds, which could be real expensive, or if it's, you know, a piece of plastic and some fake metal? Well, you can tell that because of the properties. You can tell that gold is a different texture than plastic would be, that diamond is harder than cubic zirconium or than glass would be. All these can help distinguish whether something is a material, and they can also help us decide what material we want to use for a task. Think about clay. Clay is really pliable. We can mold clay. We can turn it into different things. Now think about something like glass, let's say. Glass is not really pliable. You can not really shape it with your hands. So while clay, at least wet clay, would be something that we would maybe make a statue out of or a pot out of, glass would not be something we would want to do that out of, because, at least, again, glass as it's solid, because it's not really going to be pliable, bendable, moldable. So when we think about the properties of a material, it's not just to help us identify what the material is, it's to help us figure out what we should use for a specific purpose. So let's start by talking about physical properties. So what exactly are physical properties? Physical properties are characteristics that can be observed or measured without changing the composition of the substances in the material. Sounds a little complicated. To put it simply, you can look at it, poke it, sniff it, taste it, touch it, bend it, squish it, and it's still going to be the same stuff. So these are things that you can observe without actually changing the item at all. Think about an aluminum can, okay? So your soda can. You have that soda can. You can squish the soda can. You can crush the soda can. But does that soda can itself actually change? It's made up of aluminum, right? So as the soda can is just sitting there, you take a look at it, all you see is aluminum atoms. You squish it, still just made up of aluminum. You haven't changed the chemistry of it at all. You haven't changed what it's made up of, its composition at all. It's still the same substance, it's just in a different shape, or we've done something to it that means that it looks different. So when we're talking about these physical properties, you need to remember that these, in the end, when we're examining physical properties, we're still going to have the same stuff. So the first type of physical property is viscosity. Has your mom ever told you that you're moving like molasses in January? Those of you from up north are probably familiar with that phrase. Up north, in the northeast of the United States, that's a common phrase. Mainly because it's cold, and also because we have molasses up there. Now, molasses is a very thick liquid. It flows very slowly, and when you cool it down, it flows even more slowly. That is an illustration of the property of viscosity, the tendency of a liquid to resist flowing. So something that's highly viscous flows slowly, okay? So think about honey. Think about Aunt Jemima breakfast syrup, or whatever log cabin, whatever brand you have, the artificial syrup, not the natural stuff. Artificial syrups, corn syrup, all of that is going to flow very, very slowly. If any of your family members bake, you may have encountered Karo syrup. That stuff flows so slow, it's unbelievable. That is all an example of viscosity, high viscosity. The opposite, of course, is low viscosity, something that flows quickly. So this would be something like water or gasoline or alcohol, ethanol or propanol, hydrogen peroxide. These things all have low viscosity. If you pour them out, it's not like the ketchup in the bottle where it takes you 10 minutes to get it on your burger because it's moving so slowly. These are ones where if you were to try and tilt your ketchup bottle over, it would just squirt out all over the place. Low viscosity flows quickly. High viscosity flows slowly. Next one is conductivity. This is the ability of a material to let heat flow. So think about the metal pans with wooden or plastic handles. Why do you think we have a metal part of the pan, but then the handle is wooden or plastic or rubber? The reason is that the metal conducts heat very easily, so we can heat up our food, whereas the plastic, rubber, or wood do not conduct heat very well, which means that it keeps our hand from burning. So think about something like a copper bottom pan. Those are the really expensive kinds of like stock pots or skillets or anything like that. So if you have a copper bottom pan, the reason it has copper on the bottom is because a property of copper is that it lets heat flow very easily. So it would be a very good conductor. It would have high conductivity. Okay? The problem is it's really expensive. So what they do is that they put copper on the bottom, and then they make the rest of the pot out of metal, and obviously the handle's out of something like plastic or wood that doesn't conduct heat very well. That way, the bottom of the pan can still conduct the heat extremely well. You still get that conductivity, but at the same time it's less expensive than building the entire pot out of copper. So the other way to think about this is that a good conductor is like a conductor on the train. When you have a good train conductor, people flow very easily. Everybody gets into their places very fast. Everyone moves easily. When you have a bad conductor, there's lines, people are backed up getting onto the train, you're not going to be moving very fast. Conductivity is like that train conductor, okay? High conductivity lets heat flow easily. Low conductivity doesn't transfer heat well. This is also tied into its ability to transfer electricity. The high conductivity means that electricity would also flow easily. Low conductivity, heat and electricity would not flow easily at all. This is why things like copper are great for making pots, and they're also great for making wires, whereas wood and rubber are used to prevent both burns and electric shock. Next one is malleability. This is described as the ability of a solid to be hammered without shattering. So think of that example of the clay again. If you hit clay with a hammer, what happens? The hammer goes into it and not much else. But what happens if you hit a glass with a hammer? Your glass is going to shatter. These are examples of a high malleability and low malleability. High malleability means that something is extremely flexible. You can bend it a lot. It's very bendy. Whereas low malleability means that something's brittle. It shatters. It breaks very easily. So think about two different materials. Think about gold. Part of the reason why gold is so prized is because it was easily shaped into other objects. So you could take gold and you could shape it into jewelry, you could shape it into weapons, you could shape it into money. Glass, on the other hand, although you can pour it when it's liquid, and once it solidifies, it's very brittle, so it's not terribly useful for, making things like coins. You try and hammer it out or change its shape, it's just going to shatter. So another example would be stone. Think about something like marble. Part of the reason why marble can be sculpted is because when you hammer it, it shatters, it breaks apart. So if you can control how it shatters, you can basically control the shape. So something like these amazing statues like the David by Michelangelo, that was all done very carefully by hammering away the rock. He would hammer it in and then the rock would shatter apart in just the way that he intended. So remember, high malleability, it's bendy, it's squishy, it's very flexible. Low malleability, it's going to shatter, it's going to break. Next we have hardness. Can it scratch something else? This is a relative term. Something can be harder than X but softer than Y. Think about it this way. Metal is harder than wood, right? If you have a screwdriver, you can scratch wood with the screwdriver. But metal is softer than a diamond. If you have a diamond, you can scratch the metal screwdriver with the diamond. Okay? This is why we use diamonds on things like saws that are used to cut through, say, tile and stone, amongst other things, because diamonds are one of the hardest substances known to man. That means that they can cut through pretty much anything. So remember, with hardness, can it scratch something else? Again, very relative term, and it should be one of those where you can relate it to other things. The next two physical properties are melting point and boiling point. So when you think about water, water has three forms, right? You've got ice, you've got liquid water, and you've got gas, water vapor. So at what point does ice become water? Well, you have to warm it up enough, right? Ice is very cold. You have to warm up the ice to a certain point to turn it into water. So for melting point, that's the temperature at which we go from solid to liquid, okay? So for water, this is 0 degrees Celsius. That means, and we can get into all sorts of technical reasons for this later when we get into phase changes, but this means that basically you've added enough heat, you've added enough energy that now our ice, our very cold ice, is going to now become water, okay? Boiling point is the temperature at which we change from liquid to gas. So we've got our water, we're boiling it, we're heating it up, we're adding more heat. And at that point, it's going to go from being a liquid to being a gas. So when it's boiling, that means that we're converting that water into gas. Okay? So we will go into this in more detail in phase changes, and when you get to chemistry, you're going to go into a lot more detail. But the important thing to remember for right now is that melting point and boiling point are unique for each element or each substance, which means that you can test the purity of a substance, or you can use these properties to separate substances, and we will get into more of that later. Another physical property is density. Okay, density is your mass per unit. All right, per unit of volume. So this can either be measured as mass per centimeter cubed, or it can be measured as mass per milliliter. Generally, we use milliliter for liquid volumes. We would use cubic centimeters for sometimes gases. Gases can also be measured in milliliters, but generally solids are measured in centimeters cubed. So this value is going to be unique to each substance, and it's going to be used to test purity. So think about it this way. Have you heard of 14 karat gold, 18 karat gold, and 24 karat gold? Those are all different qualities of gold based on the amount of gold to other materials in there. If you measure the density of each of those, you'll find that they're a little bit different. And you can see how close they come to our known value of the pure gold. And what that'll tell you is how close you are to being pure. So chemical properties. What are chemical properties? Why are they different from physical properties? Chemical properties are the ability to produce a change in the composition of matter. So basically, how does it react with other materials? Now you got to remember that chemistry started from alchemy, which means that we started by basically having a bunch of guys sitting around saying, let's see what happens when we mix these two things together. Sometimes it goes well, sometimes it doesn't. But the other thing is, if you think about it, we have a lot of elements and a lot of compounds and a lot of substances that are around us every day. You've got oxygen, nitrogen, carbon dioxide in our atmosphere. You've got water in our oceans, in our clouds, in the rain, in our rivers. So there's certain things where you want to see how things react with other substances that they're going to encounter every day. And the way that they react can help us tell whether it's the same substance or if it's something different. So the first one we'll talk about is flammability, the ability to burn in the presence of oxygen. Now, this one tends to confuse people, but when we say highly flammable and when we say inflammable, those are actually the same thing. It means that something burns easily. So flammable and inflammable are the same. The way to remember this is inflammable means inflames, burns easily, inflames. So with flammability, basically what happens on a molecular level is you're combining the molecules of whatever your element or compound is. You're combining those with the oxygen and you're making something else. That's all that burning is. It just happens to be a rather, shall we say, energetic reaction generally. So we generally get a flame and smoke and stuff like that, which is why it's something that we tend to like to observe. So what you can measure this by too as well is think about something like hairspray or lighter fluid. Those, it takes only a small amount of energy added, a small amount of heat to set them on fire, right? So that's why we use butane in lighters, and that's why it's a little dangerous to use hairspray around an open flame. This is the same reason why if you're pumping gas at a gas station, you wouldn't want to smoke a cigarette, because your cigarette, that little bit of heat from the tip of your cigarette, would be enough to set the vapors, the gasoline vapors, on fire. So those would be something that would be highly flammable or inflammable. Now, on the other hand, think about something like metal, iron, or let's say cinder block, right? A cinder block is a mixture, but we'll go with it for this example. Those are things that are non-flammable. They're incombustible. You cannot combust them. It means that they don't burn easily at all, right? Generally what you'll see is that something like iron, it won't burn, it will actually melt. So some of you may remember what happened when the Twin Towers fell, that the metal melted. What wound up happening there was it got so hot that the steel in the girders melted. But even at that high temperature, the metal still did not burn. So you could say that steel is very non-flammable. It's very incombustible. Another chemical property is reactivity, how readily it combines with other elements. Now, one of the most reactive elements that we have is oxygen. It's highly reactive. It combines with other elements easily. Think about things like rust on iron or tarnish on silver. Those are examples of combining oxygen with another element. Now, in those situations, we actually do define our reactivity by how it reacts with oxygen. So like we could compare iron, silver, and gold. We would say that iron is more reactive than silver because iron rusts far more easily than silver tarnishes. So iron is more reactive than silver. It reacts with oxygen more easily. And we would say that gold is not very reactive at all because it doesn't rust or tarnish. It doesn't react with oxygen hardly at all. So we can basically define reactivity in relation to other elements, like how readily it combines with something like oxygen, and we can also define it with general reactivity, like how oxygen is a very reactive substance. Things like fluorine and chlorine are very reactive substances. Now, low reactivity doesn't combine with other elements easily. These are going to be your things like gold. They're going to be things like lead. Things that just, they're happy the way they are. They don't feel like messing around with other things. And we will get into this a lot more when we get to the periodic table because we can actually classify elements based on their properties. So let's go through a few examples and figure out whether they are physical or chemical. So here's what we observe. Aluminum is used to make lots of products because it is easy to shape. So do you think that is a physical or chemical property? Well, if you said physical, you would be right, because this is talking about malleability, the ability to bend, shape, or flex something. Now, we also use aluminum because it doesn't corrode when exposed to oxygen in the atmosphere. This isn't to say that aluminum doesn't corrode at all. It does corrode, but it's not going to corrode if you just leave it sitting out. It takes a little more than that. So, physical or chemical? If you said chemical, you would be correct. This is an example of reactivity. So what about We cover the space shuttle in ceramic plates since ceramic plates don't transfer heat very well. This would be an example of a physical property. This is talking about our ability to conduct heat and to conduct electricity. Now in this case, ceramic would be a poor conductor, a bad conductor, because it's not letting the heat get through. Now what about wiring being made of copper because it conducts electricity easy? Well, if you said physical, you would be correct. Once again, we're talking about conductivity. In this case, copper is a good conductor. Okay, so now we've got wood burns easily and is therefore frequently used as fuel. So would that mean it is a chemical or physical? If you said chemical, you would be correct, because this is talking about the flammability of wood. It is very flammable. It is inflammable, in flames. Wood is also soft and easily scratched by most other materials. So would that be physical or chemical? That would be physical, because we are talking about hardness. Hardness is our ability to be scratched by other things. Remember that. Alright, so let me know if you have any questions, and this file will also be available on class.